All right, this week we are going to be talking about combining like terms. So first, let's look at this picture. Here you have like you and your friend or your sibling or your parent. You're going through the drive-through of McDonald's, Wendy's, Burger King's, White Castle, whatever, right? You ordered 2 burgers, 1 fry, and 1 drink. Whoever you're with orders 3 burgers, 2 fries, and 2 drinks. Now, what you see from the first picture of the food to the second picture of the food is they combined the things that are the same. So they grouped the same items together. So the burgers all went together, the fries went together, and the drinks went together. All right. You can't combine burgers with drinks or drinks with burgers or fries with drinks or fries with burgers because they're not the same thing. And also, these things are usually priced differently. So it doesn't really make sense to group burgers with fries or a fry with a drink. If we look at this picture, we have a typical question is simplified to A plus 3B plus 3A. Well, A can be apples, B can be bananas, and again, A is apples. So we have 2 apples, 3 bananas, and 3 apples. So what did they do? Well, they combined their apples because they're the same. So 2 plus 3 is 5. We have 5 apples and 3 bananas. Now, you can combine red and green apples. They look different because they're different colors. However, they're still apples, so you can combine them. All right. This will make more sense when we go through some of the next slides. The next thing you can't combine plantains and bananas. They look similar, they might taste similar, but a plantain is not the same as a banana. We cannot combine those because they're different fruits. So what does it mean to combine like terms? It means we add and subtract a lot of things. We add and subtract our constants. We add and subtract the coefficients that have the same variable. We add and subtract coefficients that have the same variable raised to the same power. All right, so if we look at our picture over here, we have x to the second power plus 2 plus 6x to the second power plus 3. In blue, they identified 2 and 3 are constants, so 2 plus 3 is 5. They also identified that x to the second power and 6x to the second power are also like terms, so we can combine them because they have the same variable raised to the same exponent. So that becomes 7x to the second power. And in this instance, this is your red and your green apple. X to the second power and 6x to the second power, they don't look the same per se, right? They look a little bit different because of the 6 and there's nothing in front of x. But because they have the same variable and the same exponent, they are still apples. All right, so after that, we are going to write our simplified expression in alphabetical order. So if you have an x and a y, x comes first, y comes second. And then when the variables are in alphabetical order, we then order them from the highest exponent to the lowest exponent. What are like terms? Well, like terms are constants. They are the same variables and the same variables raised to the same exponent. So as you can see in the picture, we have 4x to the second power plus 3xy minus 14x plus 7xy plus x to the second power. They identified that 4x to the second power and x to the second power are the same, so they added those together and got 5x to the second power. Then they identified 3xy and 7xy are also the same because they have x and y. So we can add those together, and that's how they got 10xy. Now, 14x, it looks very similar to the other terms. Okay? It looks like we could combine it with 4x squared and x squared, but there's no exponent, so it doesn't quite fit there. And it looks like maybe we can combine it with 3xy and 7xy, but it doesn't have a y, so it doesn't fit there either. So this is where we have to be careful. This is our plantain out of the bananas, right? We have a term that looks like it could fit in, but it doesn't. So because we can't do anything with it, we just write it at the end of our expression. So here are some examples of like terms and unlike terms. Again, like terms, these are your red and your green apples. 2x, negative 5x. Those are like terms. Yes, they have different coefficients. One of them is positive, one of them is negative. However, the variable is x, so we can combine them. Same thing with a and 1/2 a. It doesn't matter if your coefficient is positive, negative, whole number, a fraction, or a decimal. As long as it has the same variable, you can combine them. And then we have negative 2xy to the second power and 8xy to the second power. They both have x, and they both have y to the second power, so these are like terms. On the opposite side, unlike terms, 6x and 5y. Well, they don't have the same variable, so we can't combine them. Below that, we have y and y to the second power. These are the same variable, so a lot of students think, yes, we can combine them, the same variable. However, y is not the same as y to the second power. It doesn't have that exponent, so we cannot combine these. And then lastly, we have x and 7. We have a variable and a constant. We cannot combine these either. Now it's time to practice.